Hey guys, I hope you all are doing good. In this lecture, we will try to understand what is Boolean expression. We will understand their standardized forms and basically how to convert a truth table to a Boolean expression, right? So these are going to be some important concept to understand. Um, but why do we convert it in the first place to a Boolean expression? So the basic idea is, right, that for any expression, right, let's say I'm trying to solve a problem. In order for me to convey to the computer, I need to convert it into some kind of expression, right? And that is where converting it into SOP and POS form comes in play. So let's first try to understand what is a Boolean expression. A Boolean expression is basically made up of Boolean variables and Boolean operands, right? Which is, it can have the or, sorry, the and, or the negation sign, right? Just a basic example of a Boolean expression could be this over here. Now, let's try to understand what is the SOP and the POS form. Look, the very basic term is SOP means sum of products, right? So basically what this means is sum of products means we are putting products, and like each term in this equation is a product, and we are summing them all together, right? So the basic point is over here, so it's kind of like let's say a dot b plus b dot complement of a plus complement of a plus complement of a dot complement of b. Like the basic point is that if you look at it, each of them is a product, each term is a product, and all of them are summed up together, right? And this form is called the sum of products form. Second one is the POS form, which is the product of sum form. So if I take a look at it, product of sums, it's kind of basically just the opposite of it, right? So let's say I have kind of like a plus b dot product with a plus negation of b dot with negation of a plus negation of b, right? So I hope you understand what is the sum of products and the product of sums form. Remember that each term in the sum of products is a product of the terms, and in each term in the product of sums form is basically a sum, right? And we are doing a product of all the terms together. Okay, but let's try to understand the formalized definitions of it as well, right? Sum of products form expression is a sum of terms that are products of variables or their complements, right? So basically the terms are products of variables or their complements. One important thing to understand over here is that I cannot have both the element and its complement at the same time, right? I can either have a, right, or I can have complement of a at the same time. I cannot have both in the same term. That's what we are trying to say, right? So if let's say this is the term, if I had a dot a complement, this would be incorrect, right? So you cannot do this in this case. Um, Second one is the product of sums form. Each expression is a product of terms that are sum of variables or their complement, right? So the basic point is that these are the different terms that we have. One thing important to understand is that in each term that we have, I can either have that variable or I can have its complement. I cannot have both at the same time, right? So for example, I cannot have a complement in the same term. I cannot have b complement in the same term. I can have one of each in the same term, right? So I can have a complement and b or b complement, right? Okay. So now they also have names in this case. Each term is called a minterm. So all these terms, right? This b dot a complement of a dot complement of b. These are basically called minterms, right? And each of these are called max terms. Right? So just a quick summary. In the sum of products form, each term is basically a product, and all those terms together we are summing them up, right? In the product of sums form, each term is basically a sum, and we are doing a product of all those terms together. Second thing is, in each term, a term in the sum of products form is called a minterm. A term in the product of sum form is called a maxterm. Third thing that's important to understand is that in each term, whether it's SOP or POS, we can either have the variable or its complement. We cannot have both at the same time, right? Um, I'll try to explain the general idea behind it, but the basic point is that if I do A dot A complement in the same equation, what do you think this results in, right? This would result in the zero value. And let's say I had multiple terms in this case, right? Let's say I had A dot complement of A dot B dot C dot D. Let's say I had a big equation, but this, because of this results in a zero, this entire equation would result in a zero as well. So it wouldn't really matter. That's what I'm trying to say, right? So that is why we either use the A value, a variable, or its negation, because using both will basically mean that that equation is not really important at all, or that term is not really helping us at all, right? Second thing is, and same is with the sum, right? So think about it. If I do A plus complement of A, this would always be equal to 1 if you understand the complement laws. So that basically means is, if you think about it, if this is 1, then this product, let's say I have A plus complement of A plus B plus C, whatever it is, right? It would always result in 1 because I have A plus A complement. So it doesn't matter what are the values of B, C, and whatever variables I have, it would always result in 1. So this term would not be useful to me at all, right? So that's just a basic reason why we don't have both the complement and the variable in the same term. Okay, so I hope you were able to understand minterms and maxterms along with what is a Boolean expression, right? Now, let's try to understand how we can use the truth tables to convert them into SOP or POS form. Okay, so let's try to understand how do we convert a truth table to a SOP or a POS form, right? For this example, I'm using like a big case where we have 3 variables instead of just 2, right? So it will make things a lot more clear in my opinion. So what we have is, we have a truth table, we have the variables A, B, C, and we have been given what the final equation results in, right? It could be any equation, it could be maybe A dot B plus negation of B plus C, etc., right? But what we have been given is that this is the result for each of the combinations of the variables, right? So I hope you're able to understand what the truth table has given us. Now, why do we need it, right? Let's first try to understand what is the exact importance of this. So what happens is, let's say I give you some kind of a logical expression, right? Or maybe I give you some kind of a problem to solve. But first thing for what I need to do is to convert it into some kind of a Boolean expression, right? So first thing what I would do is I would try to convert that problem into a truth table, and using that truth table, I would try to convert it into a binary, or I should say a Boolean algebra equation, right? So that is exactly what we are trying to do. In this case, let's try to just assume that this was actually a problem for which we have drawn the truth table, and now we are trying to solve or figure out the equation for it, right? Now, there's two ways we can find the equation, which is either it could be the SOP form or it could be the POS form, right? Okay, so let's try to understand how do we figure out the SOP form. So there are a few steps to it. I'll tell you the steps in detail, right? The first step is I need to take a look at all the points where the function results in a 1, right? Where the final equation results in 1. So find where f is 1, right? I'm sorry if I make any grammatic mistakes, but it's basically, I think that's correct. So basically find where f is 1, right? This could be any equation. We are just looking at the values, right? So I have this over here, right? This one. I have this one. I have this one. And that is basically it, right? For the rest of the values, the f is 0, right? So we have found all the points where f results in a 1. Second thing, what I need to do is I need to find all the terms and add them together. Remember, this is the sum of, this is the sum of products form. So what I need to do is I need to do the product of each of these and then add them together. Let's try to understand how we do it, right? So for each of these terms, let's say this is term 1, this is term 2, and this is term 3, right? What I need to do is I need to find a way to product them together such that f results in a 1. Think about it, right? For the value of a 0, for the value of b 0, and for value of c equal 1, how can I make the function or the variable result in 1? Think about it, right? A dot b dot c equal 1. But how is this possible? How can I make this happen when the values of a is 0, b is 0, and c is 1? The very simple thing is I can take the negation of a, which will be 1. I can take the negation of b, which will be 1. And I can just take c because it is already 1 in this case. And I know that 1 dot 1 dot 1 will be equal to 1, right? So what I basically need to do is for each of the terms, I need to convert them to a 1. If it's already 1, then I leave it that way. Otherwise, I take a negation of it, right? So in summary, this is what I do, right? I see this term 0, 0, 1, right? What I do is since a 0, I take the negation of a, dot product with b 0, I take the negation of b, c is already 1, so I don't have to convert it. And this will be one of my terms for my final SOP form, right? So this one is done. Let's take a look at the second one now. I have 1, 1, 0, and it results in a 1, right? Yeah. So I do a plus sign. I add a plus sign over here. Now think about it, right? Since a is already 1, I don't have to take the negation of it. I can straight away take the value of a. B is also 1. I can straight away take b's value. But in this case, since c value is 0, right, that means I need to take the negation of it in order for the product to be 1. So what this means is I basically do negation of c in this case, right? Plus, I also have the one final term where it results in a 1, right? In this case, a is 1, b is 0, and c is 1. So all I need to do is I do a dot negation of b dot c. And this over here will be my final equation for this entire truth table. Now, you can verify it. You can check whether it satisfies all the conditions. You can try to input the values 0, 0, 0, and you will figure out that it follows this entire function in this case, right? So this was the SOP form. I'll write down the steps as well. Find where f is 1, 2, find the minterms, right? Find the minterms. How do we find the minterms? We basically take variable if it is 1, else take its complement, or I should say its negation. Okay, yeah. Third one is add all terms. Okay, so I hope you were able to understand how this works, right? Each and everything. Now let's try to understand what is the product of sum form. Now, the product of sum form, if you understand the sum of product form, then the product of sum form is basically the exact opposite of this, right? How is it opposite? In this case, instead of finding where f is 1, right, I'll just change the steps to show you how they're exactly the opposite of each other, right? So now if we look at the POS form, find where f is 0, right? So we basically look at where the function is 0. We find the max terms, right? Third, what we do is take the variable if it is 0, else take its negation. So now we're going to take a look at where all the values of f is 0 instead. And also we want to make sure, we want to see that the sum results in a 0 value, right? Then last is, instead of adding them together, product all terms. Okay, so let's take a look at the example in this case, right? Okay, first of all, let's find, I'm trying to figure out the product of sums form for this question. Let's take a look at all the values where the function is 0, right? So one is this over here, second, third, fourth, and fifth, right? Okay. What I'm trying to do in this case is I need to add them together in a way so that the f results in 0, right? Think about it. Since a is 0, b is 0, and c is 0, I don't have to take the negation of any of them, right? So I can simply write this as a plus b plus c. This is one of my terms for the product of some form, or I can say this is one of the max terms in my case, right? Second is I have a0, but in this case b is 1, right? So I need to take the negation of b in this case, right, in order for the final result to be 0. So what I do is I do a dot, I do a plus negation of b plus c. Think about it, right? A is 0, so I don't take any negation. B, I take the negation because it is 1 in this case. And C, since it's already 0, I don't have to worry about it either, right? This is the second term. Third is, they're all 1, so I have to take the negation of each and every one, right? Fourth is, A is 1, so I have to take the negation of it. And finally, I have A 0 and B and C are 1, so I have to take negation of them. And this over here would be my final product of some form for this truth table in this case, right? So I hope you were able to understand how this works, right? The general explanation for how to find the SOP or the POS form is you find where the function or the resulting equation is 0 or 1, right? And then you find either the minterms or the maxterms, right? You write down the terms for each of the corresponding values of it, right? For SOP, you look at the values where it's 1. For POS, you look at values where it's 0, right? And then you basically just form the, I should say, terms itself, right? So in the POS form, each term is a sum, and we do a product of all of them together. And in the SOP form, each term is basically a product, and we sum all those terms together, right? So I hope you were able to understand how we solve or figure out the SOP and the POS form. Now I'll be giving a bunch of questions for you guys to solve, and I'll see you guys in the next lecture. Okay, I've given two questions on the board. The first one is very simple, right? So just convert the truth table to the SOP and the POS form. The second one is convert to the SOP form, right? For this one, there's basically two ways you can do it. So maybe what you can do is you can reverse engineer it and find the truth table for this, right? So this is basically, first of all, in the POS form, meaning this equation has been formed wherever the corresponding values are 0, right? So using this equation, maybe you can form the truth table, and then instead of taking the zeros, you can consider the values where it's 1 and then solve it, right? But I'll just give you a shortcut method how you can do it. First, take complement of the entire function. Second, apply De Morgan's law. Third, take complement again, right? So this is going to be true for either converting POS to SOP form or SOP to the POS form. First, take the complement, apply the De Morgan's law, and then take the complement once again. And you can also verify maybe using the truth tables and the shortcut method whether it's true or not, right? So I'll leave it up to you guys. And if there's any doubts, I'll put the answers in the description as well. Now, I'll see you guys in the next lecture.